Hey guys, in this video we're going to talk about in general how to solve scheduling problems, especially in USACO. So we're gonna look at greedy algorithms, and in this specific video we're gonna also see how to use a priority queue in Java. So let's get to it. So this problem, I'll just summarize it. So it's a classic scheduling problem. The thing is, it's greedy, obviously, because you're trying to maximize something. In this case, we're trying to maximize the amount of milk produced. Let's just call it total. It doesn't really matter. I'll just call it T. Actually, T stands for time. Let's just go ahead and write it, I guess. So the total, this is the thing we're trying to maximize, right? That's the greedy part of it. And then there's some constraint. In this case we have to schedule, and it's obviously time in this case, but it doesn't have to be. It could be something more subtle, like, I don't know, resources or something. But yeah, for this one it's just simply time. So each cow, to milk each cow, it takes 1 unit of time, and then we have only at most 10,000 units of time, okay, to milk all the cows. However, each cow also has a deadline. If you don't milk that cow by that deadline, it will produce no milk. So basically it's useless to milk that cow if you pass the deadline, is what it's saying. It's just a waste of time, essentially. So each cow has a amount of milk it produces, and each cow has a deadline. Our goal is to maximize the total uh, amount of milk that can be produced given those constraints. Okay, so let's look at the sample real quick. It's pretty straightforward. So the 10 is the amount of milk it produces, and 3 is the time deadline. And we obviously start at 0. So in the first second or so, let's just call it seconds, go ahead, and because it's easy. In the first second we have two options, 8 or 2, right? So we'll obviously go with 8. So that's 8. Let's add it to total, and then there's nothing in second, but you can't really milk this 2-1 cow because its deadline already passed. So but you can obviously milk this cow right here, 10-3. And same with fourth second, there's nothing you can do. You can just go ahead and finish this by like 3 seconds, even though the latest deadline is 5. So that's a pretty easy problem, but let's make it more difficult to see how, to see the subtleties these problems can present, and like the difficulties in general. So let's make it, instead of 8-1, let's do 8-1 2-2. Let's see. Oh yeah, this is a good one. 10-3 and 7-3. You can quickly see what I'm trying to do here, right? Because if you just go by linear order, or so you'll just add 8 first and 2 next and 10 next, because 10 is better than 7. However, there's a trick here. 7 is better than 2, right? So you'd actually want 7 to go before 2, but you have to find a way to, like, kind of see it sometimes. But sometimes it could be like it could be something like 8. If it was 8, then there's no way you could replace it. But since this 2 is less than 7, we should actually roll with 7 instead of 2. So if you think about how we can solve it, we should always kind of keep track of the minimum value. Why? Because the minimum value is the thing that's kind of weighing you down the most, I'm sorry. Because if you have a higher minimum value, your overall total will be higher, and that's what we're trying to do in a greedy algorithm. We're trying to maximize something, right? So you should always kind of keep track of the minimum value. So that brings us to the question, what's the best way to keep track of the minimum value? And in our particular case at least, and in probably most cases in these simple problems like this, we should probably roll with a priority queue. What does it do? It's also called a binary heap if you're unfamiliar, because sometimes they just use different names. Sometimes it depends on the people and, like, the language sometimes too. So what it does, it basically keeps track of the minimum value or the maximum value in log n time, and it's much better obviously than sorting, because sorting takes n log n, right? So that's a quick intro of priority queue. It's in no way like a good description of a priority queue, but it kind of at least helps the purpose, explain what it actually does. So here the idea is we should always keep track of the minimum one, so that if we ever come across a better option, we'll just replace the minimum option, minimum one with the better option, and we'll keep doing that as long as we need to or we can. You know, now actually let's do this. Actually, let's do 8 4 and 9 4. Now it again. So once we actually replaced 2 with 7, right? Because 7 is obviously better than 2, and we can simply add 8 because we didn't go to 4 yet. We still have one more slot left, right? However, if you look at this, we have a 9. 9 is obviously better than 7, so we would actually keep replacing this. So it's not like one time thing. It can keep happening like multiple times. So a priority queue is the obvious solution here. So let's take a look at code. It's pretty easy to implement. So the thing is, we have to sort. Why do we have to sort? Because the deadlines are random. Like when we get the input, the deadlines are not in like a sorted order. So we have to put them in a sorted order so we can kind of process them linearly as they come, and find the best or most greedy solution. Okay. So this part is just a bunch of input stuff, and we sort here. The sort, it's a 2D array just for convenience. You can do it in probably other ways, make a pair data structure or whatever. And priority queue is pretty easy to use. Just make sure you import these libraries at the top right here, java.io and java.util. And so we just make a priority queue, pretty easy declaration, just like any other object or list like data structures type things. And I just went ahead and added the first element because it really doesn't matter, as you know, because the priority queue, like the condition we use always checks it. So if the first element is the worst, it doesn't matter. We'll take care of that. So there are no worries as far as that is concerned. So that's just for a little bit of implementation. It helps with the implementation. So we loop over the second element to the end. So this part, what this does is, so actually I presented this example, but in the first example, if you remember, we had like a huge gap, like 10-3 and 7-5. In this scenario, we don't really have to delete. Actually, in the example, it's 2-1, but let's just say it's 2-2, okay? So here, there's no point in deleting the 2 because 2-1 is not better than 8-1, but 2-2, it just adds to the overall value, and there are no conflicts, right, with the time scheduling. So you should go ahead and add that. So that's what this takes care of. If the current time, if we have extra time left for a current cow to, go ahead and add it, we'll just go ahead and add it. Worst things, if it's the worst one, it doesn't matter because here, the q.peak, what it does, it just gives you the value. The dot poll, what it does, it actually removes the value. Okay, so there's that subtle difference. But dot peak, it gives you a peak at the lowest value. So if there's extra space, just go ahead and add it and increment the time. And if there is no extra space, we'll just take a look. If the worst element is worse than the one we have currently, we should probably roll with the current element. So we'll drop the worst element and we'll just add the current element. And this total, we have an iterator, simple iterator, so we just iterate over the priority queue. And while it has next, we just add, it's just important to typecast into int because it's an object. Technically Java treats it as an object. So that's that, and we'll just add the println total. So that's it. That's how you solve a greedy scheduling problem. I mean, it's not applicable to all problems, but this one for sure. And priority queue, that's how you use it, just the basics of it, nothing too special. So let me know if this helped you, and thank you for watching.